So this is problem 2 of practical kinematics 1. And in this case, the truck travels in a circular path. So one of the two type of the practical kinematics, two type of motion of the practical kinematics is rectilinear and curvilinear. And in the circular path, so it will be a curvilinear motion. And they give you geometry of this curve, is the radius 50 meter, and the initial speed 4 meter per second, and from the initial distance, so short distance from s equals 0, so that the initial distance, is speed increase, so speed increase, so the change in speed v dot equal to 0.005 s. And in this case, as you can see that here, distance, not seconds, not second. So the change in speed, basically, that will be the tangential component of the acceleration. And where s is in meter, so that stands for the distance there. And the question is determine speed. So basically, speed is the magnitude of velocity and the magnitude of acceleration after it's moved s, so the distance moved 10 meter. So from here, you can see they give us initial velocity, initial distance s equals 0, and the tangential components of the acceleration, and the final position or the final distance s equal to 10 meter. So we want to find out the relationship between velocity, acceleration, and distance, given the information that provided in this problem. And again, we can start with the tangential component, which is given. And as we already know, tangential component of acceleration is equal to the first derivative of the velocity with regards to time. And for this problem, they don't mention anything about the time, the t. So we need to transform this equation into another variable that is given. For example, in this case, the s, the distance. So with that, we multiply the denominator and numerator with a ds to introduce the distance s into the equation. And from that, I can have a t equal to dv over ds, and then ds over dt. So just very similar in there. And it, as we already know, the ds over dt here is actually the velocity. So let's do that here. We can say, but ds over dt equal to v. So if I plug that in that equation, so I have again at tangential components equal to ds over dt v and dv over ds. And then we can time both sides of this equation with ds, so I can have at ds equal to v dv. So as you can see, we transform from the relationship between tangential component, velocity, and time. And since the problem don't give us time, t, so we transform that equation to the one with the tangential components of the acceleration, the distance s, and also the velocity. So with that, we can take the integral of that one. So let's take integral of that. So we write that at ds equal to v dv, and integral both sides. And the initial condition, you see ds, so initial condition is s equals 0, and the final instance s equal to 10 meter. So as you can see here, we can have the s1 equals 0, and then the final, it will be 10 meter. Similarly for velocity, they start at 4 meter per second, and the question asks what is the magnitude after it's moved 10 meters, so that is unknowns. So we have that either v1 equal to 4 meter per second, and the v2 basically that we want to find out. And this actually very simple integral. So we can at ds, and we can replace that with the at equal to 0.05 s. So we can have that 0.05 s es, and then we have 0 to 10 equal to 4 to v2. The question we want to find out v dv. And from the simple equation sds equal to with the integral, so we have that rewrite at 0.005 sds will be s squared over 2, and go from 0 to 10, it equal to v dv equal to v squared over 2 from 4 to v2. So we plug in, we can have 0 plug in, nothing, 10, so you can have that equal 0.005 over 2 10 square equal to v2 over 2 square minus v1 is 4, so you have 4 square over 2. And from here we have one equation, one unknowns about v2. So from that I can have v2. From that equation we have v2 equal to 4.58, and s in meter, time is in seconds, so we can have that here meter per second, and that is the speed, so we can answer that one there. Okay, and then if we go to the acceleration, magnitude of acceleration, keep in mind this is circular path, so it curvilinear motion. There will be two components of acceleration, tangential and normal, so we can do the same in there. So we can have in terms of acceleration, so I can have at, it already give equal to v dot here, and the equation is 0.05 time distance s as given in the problem. You can plug in 0.05 up to 10 meter, so it will be 0.5 meter per second square, the SI unit of acceleration. And then the magnitude of the normal components, that very important. Don't forget that in curvilinear motion, the normal, what is that? So if the final position of the particle destructs in here, so the normal acceleration in that case, it go to the center, and you can see there, and that is an, right? And then if you see increased speed, so the trucks at this time it accelerate, so the AT, it will be tangential to the path and in the same direction with the motion, so that you have AT. So AN in this case, if you recall, that equal to B squared over the rho. Rho is stand for radius of curvature, or the radius in this case, and we have V in this case, the V2 we already have 4.58 square divided by rho. That is the radius 50 meter of this circular path. So let's plug in 50 meter. So from that we can have equal to 0.420 meter per second square. So the tangential components and normal components of the acceleration are in the right angle. So the magnitude of the total acceleration is equal to, if you recall, it will be square root of AT plus AN squared. Plug in, it will be 0.4 0.5 0.5 square plus 0.420 square, and with that we get 0.653 meter per second square, and that is the magnitude. So we can underline, this is the answer for the magnitude of acceleration. And if you want the vector, if at that instant the location of the truck there, so the resultant or the total acceleration of the truck at that instant, it will be there. That is A, and in that case, as you can see, it equals 2.653 meter per second square. So with that, hope you can get it. Bottom line, as you can see, there's some transformation, depends on the problem given. We need to transform by replacing the t with the ds, we see, and the distance with the given in this problem.